Hi folks, I'm going to be going through the solutions to review sheet number 2 for the log review sheet number 2 in preparation for your test. So we'll see how many problems we can get through in this video, and I'll probably have to split it all up into 2 separate videos. In any event, let's look at the first problem here. It says that ln of 3 is equal to a, ln of 4 is equal to b, express ln square root 48 in terms of a and b. And so we're going to have to do some finagling with this before we can go ahead and substitute in. We need to figure out a way to represent 48 with factors 3 and 4. So we know that actually 48, you can do 12 times 4, you can do 16 times 3. Either one of those works. They both use 3 and 4 in there, so we can break this up into factors of 48. So there's a couple ways you can do it. All of them lead to the same answer, but let's start with the ln of the square root of 48 is the same as saying the ln of 48 to the 1/2 power, which is then the same as saying 1/2 ln of 48. And now let's go ahead and break up 48 into some factors. We can break that up into, like I said, 16 times 3. So if I were to write that out, that would be the same as 4 squared times 3. Okay, so if I were to go ahead then and use my product rule first, remember this 1/2 times ln of this whole thing means that this has to be in brackets because the 1/2 applies to everything else here. So I can write this as 1/2, and then I can say ln of 4 squared plus ln of 3, and then that's the same as saying 1/2 2 ln 4 plus ln 3, which is the same as saying 1/2 of 2b plus a, which if you simplify that and distribute the 1/2, you end up with b plus 1/2 a, or b plus a over 2. Okay. In problem number 2, it asks which one of the choices is equivalent to the log of n, and this is just n. So if I take the log of both sides, I end up with the log of n is equal to the log of 7 to the 3rd over the 4th root of 6. And so I'm going to have to use my rules of logs, and I'm going to be using all 3 of them to expand this out. So that would give me log of 7 to the 3rd minus the log of the 4th root of 6, which would then be 3 log 7 minus, that's the 4th root of 6 is the same as 1/4, or 6 to the 1/4 power. So bring that out in front, I end up with 1/4 log 6. Okay, so that would be choice 4 there. In problem number 3, this is solving a log equation, so we're going to want to get this out of log form and put it into exponential form and solve it. So I have to do a few things before I can do that. So I want to isolate this log term. So I'm going to add 6 to both sides first. It would give me 3 log base 5 of x squared plus 9 is equal to 6. I can actually approach this a couple of different ways. I can divide both sides by 3. And that would give me log base 5 of x squared plus 9 is equal to 2, right? Because this is 3 times that whole thing. So I could undo the power rule and put it up here, or I can just divide both sides by 2. I'm going to end up with the same answer in the end. Okay? Now, I've reduced this to a single log on one side, so I can now take it out of log form and put it into exponential form. So that would give me x squared plus 9 is equal to 5 squared. Right? 5 is my base, 2 is my exponent. I end up with x squared plus 9 is 25, which would give me x squared is 16. Or you could subtract 25 from both sides and you end up with x squared minus 16 equals 0. Either way you do it, you end up with x is plus or minus 4. Neither one of those make this 0, so both of these would be part of your solution. Okay, positive 4 works and negative 4 works. If you were to do the power rule, undo the power rule and put the 3 here, and you'd have the 3 here, then you'd have x squared plus 9 to the third power is equal to 5 squared, and then it's just a little bit longer. It's actually an opportunity to make a lot more mistakes. So I would go ahead and do it this way first to just keep my numbers smaller in the beginning, and that makes it a lot easier to solve as you go through it. Okay? All right, let's move on then to problem number 4. It says solve for x to the nearest 10th. Remember that ln is just log base e. So I can rewrite this. I can take this out of log form. This is the same as saying log base e of 5x plus 3 is equal to 3.6. And so if I take that out of log form, I end up with e to the 3.6 is equal to 5x plus 3. Let me get my calculator up here. And if I were to do this outright, solve for x, I end up with x is going to equal e to the 3.6 minus 3, and then divide all of that by 5. So if I do that in my calculator, I end up with, let me clear all this out. Okay, so I have e to the 3.6, enter, and then minus 3 from that, and then hit enter, and then divide by 5. And I end up with 6.71, so to the nearest 10th, it would be 6.7 is my answer. Okay, number 5 is just understanding the rules of exponents here. Remember that anything to the 0 power is 1, right? So this would end up being 1 minus 1 is equal to 1. Clearly that's not true. Here you would have 1 over 1 equals 3 over 1, which is clearly also not true. Here you would have 1/3 plus 1/4 is equal to 1/7. We know that you can't just add denominators together. So by process of elimination, we know it's 2, but this is true, right? The negative exponent flips your fraction. So this becomes 3, this becomes 4, and this becomes 7. Clearly 3 plus 4 is 7, so we know that that's true. In number 6, they want us to find f of 16. So we're replacing x with 16. So 16 to the negative 1/2 power. Okay, so 1/2 power means I'm taking the square root. Put an equal sign in there. So the square root of 16 is 4. The negative moves that to the denominator, so that's the same as 2 times 1/4, which then gives you 1/2 as your answer. Okay, moving on to problem number 7. This is saying that the log of x cubed is 5.1372. It says find the log of 1000x. Okay, so a couple things we have to do here first. Let's go ahead and apply that power rule first. So we end up with 3 log of x is equal to 5.1372. Again, to isolate the log of x, we're going to divide both sides by 3. So we end up with log of x is equal to 5.1372 divided by 3. And we get log of x is equal to 1.7124. Okay, so the log of 1,000x, log of 1,000x, is the same as saying the log of 1,000 plus the log of x. Remember, there's no base written, so this is base 10. So log of 1,000 is 3. 3 plus 1.7124. Then give you your final answer of 4.7124. That's a 7 there. Okay. In problem number 8, this is similar to one of the other problems we did. It says find log base b of root 12. So log base b of root 12 is the same as saying log base b of 12 to the 1/2 power, which is the same as saying 1/2 log base b of 12. We can break 12 up into 2 squared times 3, so 1/2 log base b of 2 squared times 3. Remember, this 1/2 applies to the whole thing, so we have 1/2, and then we need some brackets or parentheses, and that would be 2 log base b of 2 plus log base b of 3. Okay, and from there you can go ahead and substitute in. So we have 1/2. 2 times log base b of 2 is 0.6931 plus 1.0986. And so then this is just plugging everything into your calculator. 2 times 0.6931 plus 1.0986. And then we'll take half of that. And so our final answer then is, oops, what is that up here? 1.2424. 1.2424. Okay, I'm going to stop the video there. I'll pick up in the next video with the rest of the problems on the review sheet.